My name is Candice and Moraga, and welcome to my diabolical laboratory. Here today, I'm going to be performing an experiment, and it will be on the stoichometry of a precipitation reaction. Now, the reaction I'm going to be doing today involves this formula up here, which is a mixture of, it seems that we have sodium carbonate in an aqueous solution. This will be dissolved in the water. And we combine that with the calcium chloride dihydrate right here, which will also be in an aqueous solution dissolved in water. Now, we know that when you combine these chemical compounds here, that you end up with a precipitate right here. That will be the solid precipitate, and that is the calcium carbonate. You also end up with another product, which is the sodium chloride aqueous here. We know because the sodium is in the alkali area of the periodic table of elements, plus we've got some water left over. Now, I did a few calculations here, and according to my calculations, if we add up the atomic weights of all of these compounds, then you end up with some calculations, and we can get some mole-to-mole ratios. A mole of sodium carbonate in this reaction. You're also going to need a mole of calcium chloride dihydrate, and 1 mole of sodium carbonate is 1.60 times 10 to the second power grams, and 1 mole of calcium chloride dihydrate is 1.470 times 10 to the second grams. So our precipitate here, the calcium carbonate, I predict that this reaction should yield 0.68 grams. That's 0.68 grams. How I concluded that was we are going to be utilizing in this reaction today 1 gram of calcium chloride dihydrate. Now, I already calculated that if I'm going to have 1 gram of calcium chloride dihydrate, which I already measured out, and I went ahead and mixed it with 25 milliliters of a distilled water here to form a solution, the aqueous solution, then I'm going to need 0.72 grams of sodium carbonate. I went ahead and already measured that out here, and what I'm going to be doing is placing that in here and making an aqueous solution with the 25 milliliters I already pre-measured of our distilled water. And then after I make that solution, I've got a nifty little filtration system to separate the precipitate after we form the reaction in this beaker here. So first, I form using my measurements with the stoichometry, knowing what we know about atomic mass, etc. I'm going to place this, combine these right here, and you'll get to see then I combine it in the beaker. We'll watch the reaction that happens. I might explode here before your very eyes, who knows? You're just going to have to pray that my calculations are correct. Then in this nifty little Parker Chiropractic University mug here, note the polka dots, muy duende, we've got this other little coffee cup here, a little paper cup, and I've got a little filtration system set up. I utilize a little bit of Hello Kitty duct tape, and I use a little filter that I formulated into this little funnel. So I've got a nice little filtration system here, and what I'm going to be doing is filtering out the precipitate that hopefully will form afterwards. And then after that, I'm going to take this out and dry overnight here, because it's night, hopefully in the morning here, I'll end up with a nice precipitate dried up. I already weighed the filter paper there is approximately 1.0 grams, and I already teared out the weighing boat here, which is actually 0.5 grams. Now we're probably going to have some percent error in this little experiment here due to precipitate clinging to the edge of the beaker there, and also due to the fact that this little scale only measures to the 10th place of the gram, which means that I'm going to not going to be able to have it as precise because I calculated the amount I needed to 0.72. So we've got a little bit of uncertainty there. Let's go ahead and see how this reaction occurs here. And we'll see that in 2 shakes for lamb chops tail. I just wanted to make sure that the camera was working fully here. Are you ready? Hope these aren't my last words. I once singed my hair during an experiment. We use our little glass stirring rod. That's my diabolical laughter. Okay, here we go. Ooh, neat. Looks like we have some sort of white solid here forming. And I'm going to be measuring this out. I'm going to filter this out now. The instructions specifically said to make sure that it doesn't overflow. We've got this mug here for support, and it's pretty slow moving on the filtering because it's so thick with that precipitate. But we'll slowly but surely filter it out. Looks like I'm running over on my time here, so I won't bore you. You're not going to stay overnight to watch it dry. But then I'm going to measure it out and calculate the percent error and the percent yield, which will be the percentage between the actual yield that I end up with and my theoretical yield here of 0.68 grams of calcium carbonate. Thank you for watching this installment of my diabolical laboratory in our stoichometry of a precipitation reaction. Are ionic compounds fun? See you next time!